right. Hi, everybody. I'm Paige Roberts, Open Source Relations Manager for Vertica. And before I get started and forget, Vertica is raffling off some Apple AirPods and stuff. So go check out their booth. So without further ado, I will share my screen and dive in. So what I'm going to talk to you today is about unifying analytics architectures so that you serve both the needs of the BI team and the needs of the data science team. The goal, of course, is to kind of unify how people are doing things so that we don't have duplicates of data, duplicates of pipelines, inconsistencies, all kinds of problems caused by having data in multiple locations and teams that all need to analyze data having to work in different places. Now, the other thing that this newer architecture that I'm seeing more and more of helps with is that it makes it easier to deploy machine learning models. A lot of machine learning models never make it into production, and that's just sad. So what I'm going to talk about to you is a data warehouse or a unified architecture that makes it as easy for a data science team to deploy a new algorithm, a new model, a new prediction into production as it is for a BI team to deploy a new report or a new dashboard. So that's the idea. And one of the things I want to talk about is the fact that every company that is doing really cool cutting edge data science, predictive maintenance, and smart agriculture, and software optimization, clickstream optimization, security analytics. Jaguar is doing race car analytics using all the IoT sensors on a race car to make it run faster in the next race and to predict if something's going to have a problem so they can stop at the pit stop and replace a part before it even breaks. So the kind of things that we're doing are really amazing in pretty much every industry. But all of those industries that are doing cutting edge cool stuff are also still they have to do old school BI. They still have to know what was my revenue last quarter? How are my trends? Which quarter tends to be higher than other quarters? What's the what should I stock in this location versus that location at this time of year versus that time of year? All of the normal business intelligence didn't go away, just added on top of what we were already doing. So how are data architects handling that? And I think one of the ways they're doing that is combining the old with the new and creating something entirely different as they're moving forward. So I'm going to start by setting the Wayback Machine. I've been in the data management industry for 25 years, almost. In April, it'll be 25. And I don't want to admit I'm that old, but this architecture is older than me. So data warehouse architectures have been around a long time in a business where everything changes at a ridiculously high rate of speed. The reason this architecture has stuck around for so long is several strengths that are built into it. One is the idea that I could do analytics on any particular piece of my data, of my company, my organization. Before, I could go look at my my CRM and get customer information. I could go look at my ERP and get financial information. I can't get all of it. I can't get the whole picture. Some of it's strapped in spreadsheets or CSV files, or maybe I need weather data that's coming in from some completely different place. It's like if I consolidate all of that data into one place and then do the analysis, I get a whole picture, and that's powerful. And also, I do this with SQL, and that gives me high performance. It makes it super easy to use because, hello, anybody who uses data for almost anything knows how to use SQL. Plus, all of your BI tools, all of the visualization tools out in the world right now, they almost all use SQL on the back end. So uh, if I have a dashboard in Grafana or Tableau or Power BI or whatever my dashboard is in, if I drill down on that dashboard, what it's going to do is send SQL back at a database. And that's how it's going to get the answer to display to me the new information. So they all use SQL. There's a army of business analysts who know how to use SQL. This is pretty powerful. So that's why the data warehouse has been around a long time. That's great. It's got all these wonderful strengths. It's great for reporting and business intelligence. It has high performance. I mean, super high performance. These things are optimized to the nines. They spent decades trying to make these things faster and trying to make them so that they could handle more and more jobs simultaneously without slowing down. So I got 30 users, not a problem. I'm trying to do 4 different workloads, not a problem. That level of concurrency is something that even now is a pretty powerful capability. Plus that reliability, that security, that governance that you get from 30-year-old mature software, um, stuff that really is well optimized for all of the basics of business. That's powerful. However, data warehouses are not what everybody is using now. Not if they want to do data science and business intelligence. Why? Well, back in the day, at least, some of this has changed over time. Data warehouses have evolved, just like data lakes. But back in the day, they were hugely expensive to scale. It wasn't cheap to go buy you a new Netezza appliance. That was not an inexpensive thing to do. It also costs a lot of time to try and migrate into this bigger box that you needed in order to do business intelligence at a higher scale. It only did structured data. So you had to take all of your data from all of your sources and transform it into this row and column perfect structured format, which was highly optimized. So, you can analyze it really fast. But if you had some unstructured message data or you had log data from coming in, streaming really fast from, say, your IoT sensors in a car or a jet plane or something like that, it's like you couldn't do that. That was not a thing that data warehouses were built for. They were only built for business intelligence, not for data science, not for a lot of the advanced analytics, not for geospatial, not for time series analysis, not for a lot of those things. And it couldn't handle that data streaming in because it had that ETL component, which says I have to extract all my stuff, transform it to the format that I need it in, combine it, enrich it, do some data quality to take out duplicates and fix everything so it's just exactly right, and then load it into my analytical database, which is kind of the heart of the data warehouse. And a lot of times people use data warehouse and analytical database interchangeably, and I don't think that's quite accurate, but I get it. That's like the heart of it. So what that meant was we had this highly performant, optimized to the nines, wonderful database that could give us answers really fast on data that came from yesterday. Because a lot of times we were scheduling that ETL for like 3 a.m. because that was the only time we didn't want to bog down our database ingesting all that data, much less, oh my gosh, don't do any transform in the database, because even though it's really fast and efficient for transforming data, that'll slow down my queries. That'll slow down my dashboards. So can't have that. Okay. So you can see where there's some serious weakness here. So what did we do? Did we fix the data warehouse architecture? No, we did not. As an industry, we threw it out the window and we started over. So we created this new thing called a data lake architecture. And this is a very simplified diagram because the data lake architecture was never one thing. It was really a whole lot of things sort of loosely coupled together to make a thing. And This architecture is only about 10 to 15 years old, depending on how you look at it. Really, less than 10 years old that it's really been out there in the world. And the reason that it took off so fast is because it also has some strengths. In particular, it tackled the things that data warehouses didn't do well. Um, it can handle streaming data. You can pull that streaming data in all the time, and it doesn't have a problem with that. It will ingest that data all the time and do the transformation inside the data lake. So one of the things that data lakes are really strong at is doing ETL. So instead of extract, transfer, load instead of ETL, what we ended up with is a lot of extract, load, and then transform in the data lake. So that's pretty common. And you can take in everything. I mean, streaming data, unstructured data, structured data, semi-structured data from third parties, data from wherever. It doesn't matter where your data came from. You could dump it all into the lake, and that leads to another problem, which is keeping track of it all. But I'm not going to tackle that. That's go talk to the folks that are talking about data governance and data quality and things like that. But my main point is any data you needed to analyze, you could put in your data lake. And it could scale affordably. So if I needed to analyze more data, all I had to do was buy a few more cheap, off the shelf commodity computers and scale it out. And it just got bigger and bigger and bigger. And I could hold all the data. I remember back in the day, somebody talking about their 6-month database, because that was it. That was the most they could fit in their database was 6 months worth of data. Data lakes don't have that problem. If you want to put 10 years worth of data in there, I mean, assuming you had the data lake for 10 years, which you probably didn't, but if you did, you could. I know of companies that have 7 years of data piled up in their data lakes, and that's powerful because you had to do new kinds of analytics on it. You needed to do machine learning to find those long-term patterns. You needed to find the anomalies, which maybe were fairly rare events in this huge pile of data. You needed to do a lot of cool things, and having more data enabled that. And that was pretty awesome. And being able to scale affordably is a big data lake strength. The problem is that now you have to analyze it. And at first, they didn't really have a good way to analyze it. They had MapReduce, which was kind of terrible. And it was really slow. It wasn't very performant. And it was only batch based. So you could maybe get an answer if you were a really good programmer in a few days. Probably it would take you a few months to get that really working. And then you might get an answer months to find out something. No, that's no good. So Spark came in and pretty much obliterated MapReduce. Nobody uses MapReduce in new stuff anymore. If they have MapReduce, it's because they had it and it was working and they didn't want to mess with it. Pretty much everybody uses Spark now, and that's great. But we still have that army of people who want to do SQL. So what we did is we figured out, why don't we again, data lakes involved, just like data warehouse. They've evolved to become, in some cases, more like the data warehouse in this case. So they needed SQL, so they kind of threw some SQL-like query engines on top of this. They didn't have the optimization or the concurrency or any of the other, reliability, governance, all of that cool stuff that databases had, but you could use SQL. And herein lies the big rub. If I'm a data scientist, I don't want to use Spark. Spark as an interactive, experimental, going through the all the steps of data preparation, all the steps of let me try this model, it sucks. Let me try this other model, that's better. Let me train it on this data. Let me train it on more data. Let me try a different sample. That's the problem. I had to pull out samples from my data lake because R, Python, all of the, my Jupyter notebook, all of these cool things that were created to make data scientists very productive, didn't really work on data lake size data. So if I had, 20 terabytes, much less, God, if I had, 10 petabytes of data, there's just no way I can stick that in memory on my laptop and use my Python on it. It's just not going to work. So that is kind of the problem with trying to get your model into production. All right, so let's kind of look at that. So data lakes have these great strengths. Great for machine learning and data science because it has all that data, it has all the functions. Not so great because I can't get it into deployment. That's the tricky part. Unlimited scale, affordably, because let's face it, anything can do unlimited scale if you have unlimited budget. But the ability to do unlimited scale for a reasonable price, both on premises and then eventually in the cloud. So now I don't even have to administer 100 machines. I can just spin them up in the cloud and spin them back down and use shared storage, and life is good. So that, data lakes are good with that. They moved pretty easily from on premises to in the cloud. Databases, actually, same thing. You can put a database in the cloud. That's not a problem. But the data lake had the advantage in that unlimited scale. Databases figured that out pretty quick. So now most of your databases also have that ability to scale out, that MPP distributed architecture, that ability to just add more machines and be bigger. So that's not that was an advantage of the data lake originally, and it's becoming less a data lake only thing. Streaming data, similarly, data lake was the only one that could do streaming data. Now your data warehouses can handle streaming data. Semi-structured data, a lot of your data warehouses can do that now. The analytical databases can do that now. But back in the day, data lakes were the only way to do JSON data. The only way to handle streaming sensor data, streaming logs, streaming, from IT to optimize your IT infrastructure, things like that. And complex data types. This is one of the things that they developed to make the SQL querying a little faster is, let me take all of this crazy amount of data, do ETL on it because I'm good at that, and turn it into a kind of data that is nicely columnar, which is even better than row oriented for analytics. So there we go. Very smart. So you end up with things like Parquet and Orc and things like that, that you had to refine it to get into that, but then you ended up with something that was much better for analytics and that you could store indefinitely. Very nice. Schema on read. That is a power that was purely the data lakes until recently. Now you're seeing it more and more in data warehouses, but that ability to pull in semi-structured data and then figure out what my structure should be when I'm ready to do something with it. So that's pretty cool. You'd think data lakes would have taken over the world, but they didn't. Everybody thought they would, but that's not what happened. Because their performance was slow. Even with Spark, slow performance, and Spark has to be developed and created and built and programmed pretty much by hand. So that means development and performance are both really slow. Concurrency sucks. Even now, this is one of the biggest weaknesses of databases, is that if you try and do more than 10 things or try to have more than 10 users at once, your databases will fall down. Your data lakes will fall down. They're just not built for it. It's just not designed to have more than 10 things going on at the same time. That's a problem. And it's immature tech. You didn't have the reliability, the security, the governance, all the cool things that mature tech, with a data warehouse, nobody would buy a data warehouse if it wasn't reliable and secure and all those other things. It's like it had to have those. The data lake at first didn't have to have those and has tried to add them in as time goes by. And it was very hard to operationalize your machine learning. That's the big one. It's like, I built this whole thing so that machine learning would work better, and it's the one thing it doesn't do well is operationalize machine learning. So the first thing people did was, well, I need the strengths of the data warehouse. I also need the strengths of the data lake. Why don't I just use them both? So you end up with architectures that look like this. And this is where you get your business intelligence guys working here and your data science guys working here and actually pulling samples off and going off and working on their own laptop because they can't work with this giant mess. And data lakes are complicated anyway, but you put in all that extra complication of a data warehouse, and you have a super, super complicated architecture, but it works. And that is the reason why a lot of companies now are using it, because it's powerful. It accomplishes, it has the strengths of all of those data, all of those architectures that went before it. It pulls in streaming data. You also have the strengths of the evolution. So the analytical database now has the ability to scale out because it's distributed. The data lake now has a little better governance, a little better security. You can do streaming data to both. It's just a lot of power in this, because they were starting to merge and get some of the strengths of each other, and because they were put together, that gave you a lot of abilities. So here's an example. So this is a Climate Corporation. They were a little startup, and they had this architecture, and they grew. And then they got by Monsanto, and they bought by Bayer, and now they're gigantic and a multi-billion-dollar corporation. And this is their architecture. And this has always been their architecture. So they're on the cloud. I think they're on AWS, and they're doing machine learning, some of it in their database, some of it on their data lake. They're doing their ETL there. They're using Domino to balance it. It's pretty cool. So that's kind of, I think, the one that I'm seeing the most is that cooperative combination architecture where we have both architectures kind of squished together. Now, the weaknesses of that is it's really complicated. There's a lot of duplicated effort, and still that division. BI is in one place, data science is the other. So how do I get from there to something better? I know this is a complicated slide. I'm sorry about that. But I'm just going to talk about one thing at a time. So first, unify storage. So object storage works for everything. Databases can now store their data in object storage. Hadoop can now store their data in object storage. You can put it in S3, you can put it anywhere. And MinIO is kind of a cool software because it'll simulate S3 object storage anywhere. So you can put it anywhere. VMware lets you spin it up all over the place. Specialized storage like Pure Storage and Scality and things like that let you do object storage on-prem. So you can have private clouds. So once I've put everything in the same storage, that gives me a lot of advantages because now I can query every single thing with one query engine. That's powerful. All right, well, now I do some data lifecycle management. And it's like what I want to do pretty much is take the stuff that I need that super duper performance and put it in my database format. And things that I want to store long term, put it in Parquet or Orc or something like that. That's good for, it's pretty good for analytics. I can still analyze it. But it's great and economical for long term. This is a powerful one. Unify the analytics. Get to the point where I can do SQL. If I'm comfortable in SQL, I can build a report in it. I can train a regression algorithm in it. Whatever I want to do with SQL. Or if I like Python, okay, I can pull up my Jupyter notebook. I can type in some Python, and I can generate a report. Or I can do a decision tree algorithm. It's entirely up to me. And the nice thing about that is a lot of that is built in now into this sort of unified thing I'm not sure it's a data lake or a data warehouse anymore. It's a database, and it's an analytical database, but it's really kind of unified, and that's the important aspect of it. And you can use whatever you're comfortable with, and you can query whatever kind of data format you like. And if it's semi-structured like JSON, well, I can auto parse it into my structured format, or I can just leave it unstructured and do schema on read. Either one. That's powerful. Now, the capability to isolate workloads is big because if I want to train a machine learning algorithm, that's going to take a lot of resources. If I want to do ELT, do my data transformations inside my computer all the time because I have streaming data, I can't schedule it at 3 a.m. And I don't want one to slow down the other. I don't want either one to slow down my reports. I got to be able to isolate those workloads. Subclusters are great. You can spin them up on the cloud and completely dedicate an entire cluster essentially to your workload and spin it up and down as needed. That's pretty powerful. Now, if I want to train my machine learning model here, that's great. I can save it as PMML and go put it somewhere else. Or I could trade it somewhere else and bring PMML in here. Maybe I want to train it on a GPU machine that's super expensive, but I don't want that for my giant production database because that's expensive. So maybe I trained it on GPU machine and then I put the frozen TensorFlow graph in my database and put it to work. That makes it super easy to deploy your models. So that's a unified analytics platform. And that's one of the things Vertica is talking a lot about, is that we are one. And you'll probably hear the data lake guys call it a data lake house. And that's mainly because they're starting from the data lake and they're adding some data warehouse capabilities. We're on the other end. We're starting from the data warehouse side and we're adding a lot of data lake capabilities. But what it really comes down to is there is a race for the middle. And we feel like as database companies, we have a little bit of a head start because we have that reliability, that governance, that super performance, and most importantly, that concurrency that your data lake or lake housers or what they want to call themselves right now still kind of lack. And that ability to do your analytics in the framework of your choice. So if I like Python, I can use Python and do everything. If I like SQL, I can use SQL and do everything, or whatever. It doesn't matter. So here's some examples. One of the things we're seeing a lot of is people still using their data lake, but only for ETL. So this is a good example. Philips is doing preventative maintenance, and they're just pretty much doing some ETL, taking 7 years. They actually have 7 years of data, getting their patterns, figuring out what something is going to break, predicting that, and fixing it before it breaks. And they're doing all their machine learning and their BI in the same place. Now, these guys, pretty much the same thing. I'm going to skip a little because I went kind of slow at the beginning. United Group is pretty cool because they're doing some ad targeting on TV, which I think there's only 2 companies in the world doing that, and both of them use Vertica. And they are using us both as the data lake and the data warehouse. And that is probably the wave of the future. And ironically, the TradeDesk is now using us pretty much as a data lake and spinning up subclusters as they need to generate 50,000 reports a day, because that's part of their work. And we do response speed of down to about 200 milliseconds, but they need 20 milliseconds. So they have an in-memory database to do this super fast performance that's even faster than 200 milliseconds. So there you go. So you can kind of get an idea of that unification and the advantages of it. And I think I talked too long because I only have like a minute left for. There's something you can go read. It's a radar report on various people who are doing unified analytics platforms, and somewhere where you can get some more information. I still got about a minute and a half. Let me see. Looks like I got a couple of questions. This is good stuff. Thank you, Paige. Well, you're welcome. That was an easy one. Will e-recording and slides be shared for this conference? Yes. The recording will be up later. Some of the ones that we did earlier in this conference, you can already see if you go to the lobby and click the thing that says, show me the earlier sessions. Some of them are already up. You can go ahead and look at them now. I put the PDF of my slides up, so that is available. Also, if you go to the Vertica booth, and watch their video. Right after that is like it goes to YouTube and it has a whole bunch of Vertica videos. And one of them is me giving this presentation at a different conference, a slightly longer version, because I had like 45 minutes to talk. So I think that's it. It looks like I didn't get any more questions. If you guys have any more questions, I'm going to go hang out at the booth for a few minutes. Come on over and get yourself entered in that raffle. And I will see you there.